Hello guys, welcome to another video in the series of coding. Today we are going to do the problem which is called bitwise AND of the array. So you are given an array A of n integers and an integer x. In one operation you can change the ith element of the array to any integer value, right? You have to calculate minimum number of such operations required such that the bitwise AND of all the elements of the array is strictly greater than x. Let's try to take one example. You have 3, 1, 2, 7, right? Let's try to take this example. 3, 1, 2, 7. You have these 4 numbers. What do you want to achieve? You want to get the bitwise AND of these 4 numbers to be greater than some number x. Now in our example x is equal to 2, right? So you want to achieve the AND of these 4 numbers to be greater than x, which is equal to 2. First let's see what is the bitwise AND of these 4 numbers, right? Let's quickly write the numbers down. So what does 3 correspond to? 3 is 1 1. The binary representation of 3 is 1 1. What is the binary representation of 1? The binary representation of 1 is 0 1. What is the binary representation of 2? 2 is 1 0. What is the binary representation of 7? The binary representation of 7 is 1 1 1, right? So if you write all these 4 numbers and if you take AND of them, you will get 0 0 0 as the AND, right? Because each of them has some 0 at least. So if you just take AND of these numbers, you get a 0. Again you take AND here, you get a 0. Again you take AND here, you get a 0, right? Because 0 AND with anything is always equal to 0, right? So in this case we are getting the AND as 0. Now what do you want to achieve? You want to modify the numbers. You don't like this AND. This AND is 0. You don't like this AND. You want to modify this AND to be some number which is greater than 2. Why 2? Because our x is 2. This is given in the question. X is equal to 2. In our example, when x is equal to 2, you want to modify the AND of these numbers such that you get that value to be greater than 2. Let's take one example. For example, I can very easily see if I modify these 3 numbers, right? Let me say I modify these 3 numbers and I make their most significant bit here as instead of 0 I just convert it to 1, right? So I modify these 3 numbers, then I will be able to get here the AND will become equal to 1, right? Because the AND of 1 1 1 1 1 will give me 1, right? So what will be the AND of these 4 numbers? Then the AND of these 4 numbers will be, this is 2 power 0, 2 power 1, 2 power 2. So the AND will become equal to 4, right? AND will become equal to 4. Now if the AND becomes equal to 4, right? See, if I modify these 3 numbers and I make the AND equal to 4, in this case the AND will become equal to 4. 4 is greater than 2. I would have achieved my objective. But can I get this by modifying minimum number of numbers? So I will achieve my objective, right? But in this case, how many numbers did I change? I changed 3 numbers, okay? I modified 3 numbers. When I modified 3 numbers, I am able to get the AND of the numbers to be greater than 2. Okay, can I achieve it using less number of numbers? Can I do it in anything less than 3? That is my objective. Okay, let's try to see some other answer. Let's say I make this quantity equal to 1. What will my AND be? I'll just modify one number and I make this bit equal to 1. The AND will become equal to 0 1 0, right? Because this is everything is 1 here, so the AND will become 1. What is this? This is 2 power 1. This is just 2. Now 2 is not greater than 2, right? So this is not a valid case. So I will have to modify some other digit also. Let's say I modify this digit also. So how many numbers I am modifying? I am modifying 2 numbers. What am I doing? I am modifying this number and I am modifying this number and I am making these 2 places as 1, right? So in this case, by just modifying 2 numbers, what is the AND I am able to get? I am able to get 2 power 0 plus 2 power 1, which is 3. So the AND of these 4 numbers will be equal to 3. Now 3 is greater than 2. 2 is what? 2 is our x, right? So in this case, I get a proper answer. So my answer in this case is 2. Because just by modifying 2 numbers, just by modifying these 2 numbers and making these places as 1 and 1 here, just by modifying 2 numbers, I am able to get the AND, the final AND of all these numbers I am able to get, which is equal to 3, right? Let's take another example now to understand. Let's say I have just taken some random 5 numbers. Okay, let's say I have these 5 numbers. So I have just directly written their binary representations. Now let's say, let me take some random x. Okay, let me take some x. Let me say my x is equal to something like this. Okay, I have just taken some random x. What does this x correspond to? This 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So what is this? This is 32. 32 plus 8 plus 4, right? So what is this? This is 44. So my x is 44, right? In this example, I have just taken some random example. Let's say my x is equal to 44. So the binary representation of this is this. Now I want to achieve the AND of these 5 numbers to be greater than what? I want to achieve the AND of these 5 numbers to be greater than 44. Let's first quickly calculate the current AND of these 5 numbers. If I currently write the AND of these 5 numbers, what will I get? The AND of the last date will be 0. Similarly, if I take this, I have a 0, so it will be 0 0 0 0 0 0 0 and so on. So currently the AND is 0, right? Currently the AND of my 5 numbers is equal to 0. But what do I want to make it? I want to modify these 5 numbers such that the AND changes from this quantity to something greater than 44, right? So I want to achieve the AND to be greater than 44 because my x is equal to 44. Now how do I solve this problem? So let's start from the very most significant bit, right? Let's start from that. Let's start from this quantity. So in this quantity, I see that I am having already 2 1s set up, so I cannot change them. Let me try to change these. If I change this number and make this 1 here, similarly if I change this number and make this 1 here, similarly if I change this number and make this 1 here, what will the AND of all these numbers become? I will get 1 in the most significant bit, right? Because the AND of all these 5 1s will give me a 1. So what will be this answer? So what will be this answer? See this answer, what will be this? The AND of these 5 numbers will become equal to this. Now this will be something greater than x. How is this greater than x? Because see this carefully, this number, right? This number will be greater than x because its most significant bit lies to the left side of x, right? See, x is just this, my x is this, and this number will be something greater than x. Okay, let's see what is this number, then it will be much more clear. See, this is 2 power 0, this 2 power 1, this 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, this 2 power 7. So this number is simply 2 power 7. If I change the most significant bit, I make this number equal to 2 power 7. Now 2 power 7 is 128, and what is x? X is 44. So obviously 128, which is the AND of all these numbers, if I get by just changing one digit, the last digit, that will be greater than 44. So I would have achieved my objective, right? I have achieved my objective because the AND of all the 5 numbers is 128. 128 is greater than 44. So how did I achieve my objective? I modified how many numbers? I modified 3 numbers. I modified these 3 numbers, right? So my candidate for answer is 3. If I modify 3 numbers, I will be able to get the AND of the numbers equal to 128. 128 is greater than x, which is 44. So I have achieved my objective by modifying 3 numbers. So the candidate for answer is 3. Okay. So currently the candidate for answer is equal to 3. Okay. Now let's go to the next digit. Now let's again go to the next digit. Now let's see the next digit. Now in the next digit, again let me apply the same trick. So what am I doing? See, I can modify this number. If I modify this number and make this 1 here, similarly I modify this number, I make this 1 here, similarly I modify this number and I make this 1 here, what will happen? This digit here will become 1. The AND of all these numbers will become 1 here. Now what is this? This is 2 power 6. This is 64, right? If I make this digit as 1, this will be 64. So the AND of all the numbers is equal to 64. Now that is also greater than x, which is 44. So again I achieved my objective. How many numbers did I modify? I modified 3 numbers. So again the candidate for answer is 3. Okay. So till now the candidate for answer is 3. Now let's go to the next digit. Okay. Now let's go to the next digit. Now this is the next digit that I have. Now let me try to apply the same trick on this digit. Will it work? So what I did, see, I am having these digits already as 1, right? So I need not modify them. I have one digit which is not 1, this digit. So let me modify it. Okay. So I'm modifying just one number. What will the AND become now? The AND will become equal to this number. Now what is this number? This number is 2 power 5, which is 32. Okay. This number is 32. Now is 32 greater than x, which is 44? No, it's not greater, right? 32 greater than 44 is false. So now this trick is not working. For the previous 2 digits, the trick was working. By just modifying one single digit, we were getting our answer. But in this case, 32 is not greater than 44, right? So in this case, why is this trick not working? Because now the bit is set in x. Okay, now the bit is set in x. So it's not that simple, because now we have reached this bit which is set in x. So what we'll do now, if we just modify one single digit and if we get this as 1, it will be 32. 32 is less than 44. But what we want to achieve, we want to achieve the AND of the numbers to be greater than 44. So this trick is not working. So what we will do, let me do one thing. Let me just make this still as 1. Okay, let me make this as 1 and let's go forward to the next digit, because I want to get a number greater than x. Okay, so when I want to get a number greater than x, what should I do? Which digit in x is not set, that I should modify. So what do I mean by that? See, let's consider this. Now let's say this digit in x, this is x, right? This digit, this is x. So if I take a number, right? If I take a number and if I make this digit as 1, okay, if I make this digit as 1 by modifying this number, right? If I make this digit as 1 by modifying this number, then I get this number. What is this number now? This number is 2 power 5 plus 2 power 4. This number is 32 plus 16. This number is 48. Now 48 is greater than 44, which is x. Okay. So when the digit was not set in x, what we did, when the digit is not set in x, it is gold for us. What do we mean by gold? If the digit is not set in x, right, it is amazing, because if we set that digit in x, right, see here the digit is 0, that means the bit is not set. So if we make that number as 1, right, if we make here as 1 and already whichever was set in x we keep it as such, we will get this number which is greater than x. Okay, we will always get this number greater than x. How will we get this number greater than x? See, notice what is x, 1 0 1 1 0 0, right? This was our x. Let's take this example. This was our x. What we did, see, now we saw this digit is not set, so this turned into a golden opportunity for us. Why is this a golden opportunity? If we make this digit as 1, right, and if we leave this digit also as 1, and even if the remaining digits are equal to 0, this number is going to be greater than x. This number is greater than x. Okay, why is this number going to be greater than x? Because it's the property of binary numbers, right? It's the property of binary numbers. See, this, what we did, you are setting this digit as 1, right? So even if all these digits are not set, it doesn't matter, just this digit will guarantee that this number is greater than x. See, what is this? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. What is the property of binary numbers? 2 power 4 is 16. 16 is greater than the sum of all these digits. 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. Even if you sum all of these will be 15 only. So 16 is going to be greater than 15, right? So what does it mean? Even if, see, the value, the place value of this digit is greater than the sum of even all these remaining combined digits. This is the property of binary numbers which we are going to use here, which is very important to understand. If we are setting a digit which is not set in x, right, if we are setting that, even if all other things are not set, it doesn't matter. The place value of this is so much more important than all the digits which are behind it, right? So what we did, whenever we saw a digit that is not set in x, what are we doing? See, we saw a bit that is not set in x, so it's golden for us, because now if we set that, if we modify this number and if we set it 1, right, that means we will be able to get an answer, we will be able to get the and we'll be able to get a number. Here in this case we got 48. 48 is greater than 44. We got a number 48 which is greater than 44, which is what we want, right? So for doing this, how many numbers did we modify, right? For doing this, how many numbers did we modify? Let's see what we did. For doing this, how many numbers did we modify? See, we didn't modify this number at all. We modified this number, okay, and we modified this number. We just modified 2 numbers and we got our answer, right? We just modified these 2 numbers. What did we modify? We modified 1 and 1 here, right? Just by modifying 2 numbers, we got our answer. So now our answer changes from 3 to 2. Okay, this is very important to understand. Okay, now let's try to find if we can get a better answer than 2. Okay, so what are we doing? Let me do one thing. Let me shift x below and let's try to write what are we doing. See, so what are we doing? See, we have a bit that we are checking continuously, right? For example, we started from the most significant bit, then we went here, then we went here, then we went here. Okay, now we are going to check this bit, right? What are we going to check? What are we going to do? We are going to see if this bit is set in x or not. If it is set in x, for example, even if we set this bit in x, right, then it doesn't matter. It doesn't matter because this number will either be, okay, this number will not be useful, because see, even if you set this bit is already set in x, right? So you will get a number, you will not get a useful number, you will get a number which is less than or equal to x. When is the golden opportunity going to strike for you? You are going to strike gold when the bit is not set in x, because when the bit is not set in x, then only you have an opportunity to make a number which will be greater than x. Okay, it's very important to understand this. We'll see more examples, but for now let's try to understand this. See, what we did, we started from the most significant bit, we reached here, now we reached here, now we reached here. Now again we see a bit is set. So what we'll do, we'll just set that bit, but this value is not going to give me the answer, because see, even if I set this bit, this number will not become greater than x. Let's see, what is this number? This 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So what is this number? This 32 plus 8, right? This number is just 40. As you can see, this number is just 40, right? Even if you set this bit, this number is 40. 40 is less than 44. So whenever a bit is set in x, it's a useless thing. See, whenever a bit is set in x, it's useless. When a bit is not set in x, then only it's a useful number, then only you're going to strike gold. Okay, we'll see more examples of this, then it will be much more clearer, right? So what we'll do, when a bit is set in x, what we'll do, we'll just set it as 1, right? We'll just set it as 1 and we'll move forward. Okay, let me take some variable temp. okay, or let me give a better name. Let's say bit set in x. Okay, let's say this number is bit set in x. Okay, so this number is representing the number. We are just going to set the bit in x. Okay, so let me write bit set in x. So whenever a bit is set in x, we are going to set the bit in this number as 1 and we'll go forward, because when will gold strike us? Now let's see this example. Okay, let's see the next digit. Now let's reach the next digit. Again, in this digit, what is happening? Bit is set in x. So since bit is set in x, even if we make this number as 1, right, it's, see, this number is just going to give you the number which is equal to x. It's not going to give you a number greater than x. It's useless number because this bit is set in x. Okay, so what we'll do, we'll just set it as 1 and we'll move forward. Now let's go to the next digit. Now here we are going to strike gold, because see what is happening. See this digit here, the bit is not set in x, right? This is 0, this is 0. So now if I make this digit as 1, it's awesome. I am going to get a number which is greater than x. Okay, see what is this? What is this number? Let me see again. See, up till this the number was 44. Now if I add 44 plus 2, this number will become equal to 46. So what is the binary, what does this number corresponds to? This number corresponds to 46. Now 46 is greater than x, which is 44. How did I achieve a number greater than 44? When the bit was not set in x, what I did, I struck gold. I struck gold means I quickly went and made it 1. If I am going to make this digit as 1, what do? I will also modify this. Okay, I am also going to modify 1 here. So what is happening? How many numbers have I modified till now? Now let me see. Okay, now let me see what I am doing to get. Okay, now let me see what I am doing. Let me erase these marks here and let's see freshly what I did. See, now when this bit was not set in x, right, this bit was not set in x, so what I did, I struck gold. What do I mean by struck gold? I made this bit as 1. When I make this bit as 1, I am going to get a number which is 46. 46 is greater than 44. So it's awesome. Okay, I have achieved this AND. Now I have to get this AND, right? I have to get this AND. How will I get this AND? I need all the digits here as 1. I need all the digits here as 1. I need all the digits here as 1. And I need all the digits here as 1. Okay, so let's take step by step. First of all, to make all the digits here as 1, right, here I will have to modify one number. Okay, similarly, to make all the digits here as 1, what I will have to do, I will have to modify one number here. Similarly, to make all the digits here as 1, I will have to modify this one here. Similarly, to make all the digits here as 1, I will have to modify this number here. So how many numbers am I modifying? I am modifying 3 numbers. Okay, if I modify 3 numbers, I will be able to get the AND. I will be able to get the AND of such a number which is greater than x. Okay, so currently the answer that is 3. Okay, now it is worse than the answer 2, so we will not change the answer, but even this is a possible candidate for answer. Okay, now let's go forward to the next digit. Okay, let's go forward to the next digit. So what we did, now let's go forward. Okay, let's go forward to the last digit. Now we are at this digit. Okay, now again this is not set. Okay, this bit is not set in x. So what does it mean for us? It means gold for us, because if we are able to convert and make this digit as 1, right, that means we will get a number which is greater than x. Okay, we'll get a number which is greater than x. So it's amazing. So let's try to make this number. Okay, how can we make this number? We will have to modify all these digits as 1. We'll have to change here. Again, we'll have to modify all these digits as 1. We'll have to make 1 here. Again, we'll have to make all these digits as 1. We'll have to make 1 here. Again, we'll have to make all these digits as 1. So we will have to make 1 here, 1 here, and 1 here. So how many numbers are we modifying? We are totally modifying 4 numbers. Now 4 is worse than 2. So the current answer will be equal to 2. So 2 will be our final answer. Okay, this is the logic or approach which we are going to do. Let's see more examples. I know that it has become a bit confusing. Let's see even more examples. Okay, let's quickly see some more examples. Then it will be much more clearer. Okay, let's say, let me take some random numbers. Let's say we have some number like this. Okay, let's say we have some number like this. Let's say we have something like this. Okay, and let's say we have 1 1 0 1 1 1. Okay, let's say 1 0 1 0 1 0. Okay, something like this. Let's say we have some 5 numbers like this. Okay, let me take some random x that we have. Let's say the x that we want to achieve is, let's say 1 0. Okay, 1 0 0 1. Let's say this is our x. Okay, and let's say the numbers that we have in our array are these 5 numbers. So what we want to achieve, we want to get the AND of these numbers to be greater than x. What is x? Let me write it. So x is just 8 plus 1, x is 9, this number corresponds to 9. Okay, x is 9. Now we want to achieve the AND of these numbers to be greater than 9. So what are we doing? What is the trick that we are using? See, first of all, let's calculate the AND of all the numbers. It's just in this example also it's just 0. Okay, it's just 0. So what we'll do, we'll start from the first bit. Okay, so whenever a bit is not set in x, that means what? We have struck gold. Okay, because if we can modify that bit, we will get a number which is always greater than x. Okay, let's see what is the first bit. Now it's not set in x, right? Let me write x fully. So this is our x. Okay, x is 0 0 1 0 0 1. Okay, this corresponds to 9. So now let's start from the first or the most significant bit. Okay, let's start from here. Now in this case, what we are seeing, this bit is not set in x. So what does it mean? If we make this as 1, right, if we make this number as 1, then it's gold for us. Okay, because if we just modify this bit as 1, how we can do that? We can modify one of the numbers. If we just modify this one number, what will happen? We will be able to get the AND of all these numbers as 1 0 0 0 0, which is greater than 9. Okay, what is the AND? What does this represent? This 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. This 2 power 5 is 32. As you can observe, 32 is greater than 9. That means we have got the AND of all the numbers, which is 32, to be greater than x, which is 9. Okay, so we have achieved our answer. So how many numbers did we modify? What we did, we just made the first bit as 1. So how can we achieve that? We can modify this digit as 1. So the answer is 1. Okay, currently the answer is 1. Now let's move forward. Let's see the next bit. Again, in the next bit, the bit is not set in 0. That means again what we have done, we have struck gold. So if the bit is not set in x, that means if we make this as 1, we will get a number which is greater than x. Okay, so if I make this as 1, how many numbers will I have to modify? I will have to make this as 1, this as 1, this as 1, this as 1. I will have to modify 4 numbers. Okay, so now I will compare 4 with my answer. Answer is smaller than 4, right? So I will not change my answer, because answer is already 1. 1 is less than 4, right? So I will not change my answer. Okay, now let's go forward. Let's go to the next digit. Now when we are going to the next digit, this bit is set in 1. If this bit is set in 1, even if we make this as 1, right, we will get a number which is a useless number. It will be either less than or equal to x, right? So what we'll do, we'll do nothing. We'll just make it as 1 and we'll move forward. Okay, we'll just make it as 1 and we are going to move forward. Now let's see the next digit. Next digit, we are seeing this digit. Okay, this is the next digit that we have. Now this bit is not set in x. That means it's gold for us. Okay, why? Because if I make this as set in 1, that means this number is going to be greater than x. Okay, this number is going to be greater than x. So what is this number? You can see that this 2 power 0, 2 power 1, 2 power 2, 2 power 3. So this number is 8 plus 4, 12. Okay, this number is 12. So you can see that 12 is greater than 9. Okay, so it's amazing for us if I change these two digits as 1. Now how do I check how many numbers I have to modify? I have to make these two digits set as 1, right? So I will have to modify this number. I'll have to make 1 here. I'll have to modify this number. I'll have to make 1 here. I'll have to modify this number. I'll have to make 1 here. I'll have to modify this number. I'll have to make 1 here. This number is okay. So I will have to change 4 numbers to achieve this AND value. This is the AND value. Okay, this is the AND value. So now 4 is greater than 1. So my answer, I have already got a better answer. So I'll just let the answer remain as such. Okay, so I'll not change the answer. Now let me go forward. Okay, now let me go forward. Next time what I'm going to do, let me go forward. Now I'm going to go to the next digit. This is the next digit. Now again in this digit, the bit is not set in x. So what are we doing? We are striking gold. If this bit is not set in x, if I set this bit, right, if I set this bit in x, I am going to get a number which is greater than x, which is 9. Okay, let's check. What is this? This 2 power 1. What is this? This 2 power 3. So what is this number? 8 plus 2. This number is 10. Now 10 is greater than 9, right? So I am getting a number which is greater than x. I am getting 10. 10 is greater than 9. Okay, so to achieve 10, what will I have to do? I will have to make this bit as 1 and this bit as 1. So I will have to modify this number here and I will have to modify these two numbers here. So how many numbers I am modifying? I am modifying 3 numbers to achieve this AND. Okay, I am modifying 3 numbers to achieve this AND. Now 1 is less than 3, so I have not changed my answer. 1 will still remain my answer. Okay, now let's go forward. Let's go to the last digit. Now in the last digit, what is happening? In the last digit, the bit is set. So even if I make this as 1, it's useless, right? Let me just go forward. Let me make this 1 and go forward. Okay, so this is the logic. Let's code it, then it will be much more clearer. So first of all, what I'm doing, I'm going to start from the most significant bit. Let me take one last example very quickly and then we'll move forward to coding it. Okay, let me take a simple example. Let's say we have some digits like this. Okay, I'm just writing some random digits. Okay, let's say we have something like this, and what is our x? Let me say our x is something like this. Okay, so what do we want to achieve? we want to achieve the AND of all these numbers to be greater than x. Currently, what is the AND of all these numbers? 0. What do we want to make its AND to be greater than? This is 2, right? X is equal to 2. So I want to achieve the AND of these 4 numbers to be greater than 2. Okay, this is my objective. So what I'm doing, I am first of all starting from the most significant digit. Now what can the most significant digit be? So what we'll do, we'll start from I equal to 30, I greater than equal to 0, I minus minus. What are we doing? We are considering it as a 31-bit number, and what we are doing when we are considering it as a 31-bit number, what we do, how to get the most significant bit? If we just left shift, right? If we just left shift 31 times, if we just left shift 30 times, we will get the most significant bit. So what I'm doing, I'm taking 1. If I left shift it I times, I'm starting I from 31. First time I will left shift 30 times, then I will left shift 29 times. Okay, so on, right? First we will start left shifting from here, then here, then here, then here. So what we are doing, we are coming from right to left. So I'm just taking some number, and what I'm doing, I'm checking if that bit is set in x. How will I check? This is the way to check if that bit is set in x, right? So let me just write it. See, if this is true, that means the bit is set in x. Okay, if this is true, that bit is set in x. Okay, let me declare some variable also, int bit set in x. Okay, let me initially give this equal to 0. So if this condition is true, that means that current bit is set in x. So then what will happen, the number bit set in x, right, that I'm going to just set that bit in this number also, bit set in x, right? I'm going to set that bit here also. So what I'm going to do, I'm going to set that bit in this number also, bit set in x, right? So if that bit is actually set in x, right, that means this is useless. Okay, this quantity is useless. If it is not set, in this case only we are going to strike gold. Okay, in this case we can achieve what we can achieve. We can achieve the AND of numbers to be greater than x. Then only we have that opportunity, right? Then only we have that opportunity. Okay, so if the bit is not set in x, then what we are going to do? Okay, let me take a temporary variable. Okay, let's take a temporary variable. See, first of all, okay, let me take another example. Let's say this bit was set in x. Okay, let's say this bit was set in x. So then what will this become equal to? What is this? 2 power 0, 2 power 1, 2 power 2, 2 power 3. This is 8, 8 plus 2, 10. Okay, x will become equal to 10. Now let's say I want to achieve the AND of these numbers to be greater than 10. Okay, first of all, I notice that this bit is set in x. So what I do, I just make this bit to be set in x. Okay, so I have a number bit set in x. I just set this bit in x. Okay, and I just move forward. Now let me come to the next digit. When I come to the next digit, I see that this bit is not set in x. So here what I do, I strike gold. I see that the bit is not set in x. So I have an opportunity to make this bit as 1. Okay, so if I make this bit as 1, this number will be greater than x. Okay, see, what is this number? 2 power 0, 2 power 1, 2 power 2, 2 power 3. So this number is 12. Now 12 is greater than 10, right? So if I set this bit in x, then in that case, I can get AND which is greater than 10. Okay, so how do I set this bit in x? So I'll have to take another number. I'll have to take another variable temp that I'm going to take. And what I'm going to do, see, temp, already the bits that are set in x, I'm going to leave them as such, right? But if the bit is not set in x, then it's awesome, right? Then it's awesome. What I'm going to do, I am also going to set the bits which are not set in x, right? That is what I'm going to set, right? So OR with 1 and I. So this is what I'm going to achieve, right? So when I do this, currently, see, in this example, this will be my temp. Okay, 1100. So my temp will be equal to 1100. Now it's awesome, right? See, what is x? X is equal to, let's say, what is x in our example? X is 1010, right? And what is temp? Temp is equal to, this is temp, let me write, temp is equal to 1100, right? What is my temp doing? Temp saw that, let me write bit set in x also. So I have a number bit set in x, and that is equal to 1100, because what we did, we saw first bit was set in x, so we set the first bit in bit set in x also. Now we saw the next digit. In the next digit, the bit was not set in x, so we got a opportunity to set this bit. So what we did, we will set this bit in temp. Now our temp becomes equal to this. How did a temp become equal to this? Whatever bit was set in x, we left it as such, right? We left it as such. Okay, and what we did, this bit was not set, right? 1, if you left shift I times, you will get this bit. So what was temp? Let me write it. See, what was temp? Initially temp was 0. What we did, now we saw that this bit was set in X already, so we set it in temp also. Now we saw that this bit was not set in X, so goal struck us. So what we did, 1, we left shifted I times this, and we will set this bit in temp. So this will become our temp. Okay, so finally this becomes our temp. Now what we will do, we got this number. Now we have to make this as the AND of all numbers. This quantity is the AND of all numbers. This quantity is the AND of all numbers. How will we make this quantity as the AND of all numbers? So let's iterate. Okay, for int number in our array that is given to us, the vector that is given to us. So for int number in A, okay, so we will do AND of temp with, okay, if temp AND with number, right? So we do the AND of temp, which is 1100. If we do the AND of temp with that number, okay, let's see this example. So if I do AND of temp, let's say with this number, let me erase this. Okay, so this is my temp, and if I do AND of temp with this number, right, that means what? That means what will I get? I will get again 1100. I get temp only again. If I get temp only again, that means these bits are also set in that number. Okay, that means, see, what do I mean? If I do AND of temp with number, and if I get temp, that means exactly those bits are set in the number also. That means bits are set in the number. See this example. In this example, temp is 1100 and the number that I have is 1101. If I take AND of these two numbers, I will get temp only, because exactly these two bits are only set in this number. That means that this number should not be modified. This number is a very good number, right? I need not modify this number. Which number should I modify? I should modify this number to get this AND, because if I take the AND of this number with temp, this bit is not set. So I need to modify it and I need to set this bit, right? So see, if the bits are set in the number, then let me say don't modify this number, because this number is a good number, right? Let me take a count of don't modify. So let me take don't modify the number, the count of that as 0. If this is not true, if this condition is not true, that means I will have to modify that number. Okay, so when I exit this loop, let me take an answer variable, int answer. The maximum numbers I need to modify is n, so the maximum answer I have is n. Okay, so what will my answer be after I exit this loop? Answer will be minimum of answer comma n minus don't modify, because the numbers which I don't have to modify, if I subtract that from n, that will give me the numbers that I have to modify, right? So let's take this example. In this example, this is temp. What I do, if I take AND of this and this, I will get back temp. That means this number is a good number. I don't have to modify this number. Okay, I don't have to modify this number. Let me take the AND of this value with this value. This number this number will tell me that this bit is not set. So if I take the AND of this number and this and temp, I will not get temp back as the answer. See, if I take AND of these two numbers, what will I get? I'll get 100. This does not equal to temp. That means I have to modify this number. I have to still put a 1 here. That means this number I should modify. Okay, this number is a good number. I need not modify it. This number I need to modify, right? Similarly, this number I need to modify. I need to place a 1 here, right? So I need to modify these two numbers, and I need to modify this number also. I need to modify 3 numbers. So these are the 3 numbers I need to modify. This number I don't need to modify. So my don't modify is going to keep a count of the numbers I don't need to change. But what do I want in my answer? How many numbers I need to modify? So if I take n minus don't modify, I get the answer. Okay, so now let's run and see the we have to also put a bracket here, because if we don't put a bracket, it will give the wrong answer. Let's compile and see now. So it's working. Let's just submit and see if it's getting accepted for all the test cases. So it's accepted. Thank you for being patient and listening.